This is a check of the spark and injection pulse and cam position sensor on a 1600 Mazda Miata MX5 engine. This is a 1991 engine, complete with the engine wiring harness, the battery harness and the main fuse box. The body harness has been removed for another project, so we don't have an ignition switch as such, but we can still power the circuits up. The current flow is the white wire that comes from the main fuse in the main fuse box. That goes to the ignition switch. From the ignition switch, one of the outputs is the blue wires, which are connected directly to the igniter and to the coil pack. Later engines, of course, didn't have the igniter. When we connect that up, there's also a blue connection, blue wire, which is connected to the the passenger compartment fuse box, to a 15 amp engine fuse that supplies power via this black and white wire to operate the main relay in the engine compartment fuse box. So when we connect this, we'll hear the relay click on and possibly hear the humming of the idle speed control solenoid, but it's very quiet. So now we should have all our circuits powered up. The blue wire supplies the power to the ignition coil pack. We can plug that back in, and we'll also the red and white, the white with the red stripe wire supplies all the power circuits on the vehicle. Supplies power to all 4 fuel injectors. The injectors are then operated via the ECU, are grounded via the ECU. ECU, of course, will get the power supply on that white-red wire. White-red wire will also supply power to the cam position sensor. Even the diagnostic connector will have battery power connected to it via that white-red wire. So this is also the most convenient place to check if the main relay is supplying power to that white-red circuit. You may notice I was using the conventional test light to test these power circuits. You have to be careful with this type of tester. It's considered a low impedance tester. It actually puts a load on the circuit, which is useful when you're checking power circuits. However, it can be damaging if you use it on electronic circuits. The reason I like it for power circuits is if you use the DVOM, you can get some misleading readings. Just a little demonstration, because it's a very low impedance tester, a very high impedance tester, you only need a very small current to make it operate. And if I simply touch this terminal and touch a battery terminal, I can see a pretty solid battery voltage right there. Now that doesn't mean that I can power anything up with my finger. So you can see that DVOM will sometimes give you a reading when all it's reading is a stray voltage or a little backfeed from another circuit. So that was why I used the incandescent tester for the power circuits. But for the other circuits, the non-power circuits, such as the 2 5-volt reference circuits of the cam position sensor from the ECU, we need to use the DVOM, and that reads, we have a 5 volt there, we have 5 volts there. The cam position sensor will then pull those voltages down to a low voltage to operate to trigger the coil and injectors. We'll actually have a little injector light here called a Noid light, which will connect across the injector tester. That will flash just to indicate there's a signal to the injectors. We have a little spark tester over here. That's a useful little tester, although of course you can do the same thing just by breaking the ground terminal off an old spark plug and again see whether you've got a reasonable quality spark. System is now powered up. If we rotate the engine, then we should be able to see our switching signal. I've cheated a little bit by connecting a couple of probes, back probing the connectors at the ECU. If you probe the connectors at the cam position sensor, you have to be a little bit careful because they're sealed connectors. They do make probes which will go past the seals without damaging them, but they're always a little bit tricky. So we'll connect to our probes here at the ECU, and we see we've got a low voltage on that terminal, about 0.2 of a voltage. If we rotate the engine, then we should be able to see that voltage switch if the cam position sensor is operating. We saw a flash there from the injector, so we got an injector pulse. We keep on rotating the engine. It's got a little bit of compression here. At some point we should get a spark, as well as seeing the cam sensor switching on our DVOM. There we saw a spark. So you can see you don't need to be cranking the engine, just rotating the engine quite slowly you should be able to produce a spark and a signal to the injectors. We'll just check the other circuit because there are two sets of triggers in the cam position sensor. So we'll connect to our other probe. This one is the white wire. The first one was the white with the green trace wire. I'm not sure which injectors and which coils, but that is currently at a high voltage. As we rotate the engine, we see it switch to a low voltage. Got quite a bit of compression on this one, so that's always good. Except when you're trying to, and then we saw the spark there again. It tends to spark. I'm not sure whether this is a way you can check the ignition timing. So there we see our spark. In fact, if we just move the engine backwards and forwards on that, so that sensor wasn't changing state, so obviously it was the other sensor that triggers the number one spark plug. So that'll give us an idea whether our cam position sensor is working. We see the readings we should be able to read. Fuel pump is obviously operated by the engine control module, but during cranking it gets a signal from a starter fuse in the main fuse box here, and on these early cars with the old type flap meter, as soon as any air moves, the airflow meter will actually trigger the relay. So we can, just by moving the flap, we can hear the fuel pump relay clicking. Of course, we can also operate the fuel pump relay by jumping the diagnostic connector and for testing our fuel pump. Hopefully that sort of clarifies a little bit of how to check these circuits and might be useful.